You ask Siri a private question on your iPhone, and the surprising part is not that it answers. The surprising part is that the hardest version of that answer may run through Apple privacy software on NVIDIA chips inside Google Cloud. So the real question after Apple's June 8th WWDC reveal is not simply whether Siri got smarter. It is where your prompt actually goes, who can see it, and why Apple would depend on rival infrastructure while still selling the story as private AI. For years, Siri felt less like a conversation partner and more like a voice remote. If you used the right phrase, it could start a timer, call a contact, or play a song. But if you asked something messy, personal, or multi-step, the illusion broke quickly. The old assistant world was built around commands. The new AI assistant world is built around context. A command assistant waits for a known instruction. A conversational assistant tries to understand what you mean, what is on your screen, what you said before, and which app can help. This is especially hard for Apple because Siri lives inside the most personal computer many people own. It is not just answering trivia. It may touch messages, photos, calendars, files, locations, and app actions. More intelligence is useful, but it also creates more privacy risk. Apple's answer is a hybrid AI stack. Some requests stay on the device. Some go to Apple's private cloud compute. The most demanding requests can use a larger cloud model that extends private cloud compute onto NVIDIA GPUs in Google Cloud. The key misunderstanding is thinking the new Siri is one giant brain. It is better to think of Siri as a dispatcher. It looks at the job, chooses a model, gathers the needed context, and sends the request to the smallest place that can handle it well. The first layer is on your device. Apple says its new model family includes smaller on-device models, including a core model and a more powerful advanced model for capable Apple silicon. This layer is best for fast, private, everyday tasks that do not need a huge model. Local AI is important because it can be fast and private. If the phone can understand your dictation, summarize a short bit of text, or help with a simple system action without leaving the device, that reduces latency and reduces exposure. The best cloud request is the one you never send. Apple also described a more advanced on-device model that uses a sparse design. In plain English, the full model is too large to keep fully active all the time, so the device loads the parts that seem useful for a particular prompt. It is like pulling only the needed tools from a large toolbox. But some questions are too complex, too broad, or too heavy for a phone to handle comfortably. If Siri needs deeper reasoning, more context, image work, or agent-style planning, the request may move upward to Apple's server models running through private cloud compute. If this kind of under-the-hood explanation helps you follow AI news without the hype, consider subscribing. We are going to keep tracking the real architecture behind the big announcements because the details usually matter more than the keynote slogan. Private cloud compute is Apple's attempt to make cloud AI behave more like an extension of your device. The promise is that when a request is handled there, personal data is not stored, not made available to Apple, and processed only by approved software that can be checked by researchers. That does not mean the cloud disappears. It means Apple is trying to reduce what has to be trusted. Instead of saying, "Trust us because we are Apple," the design leans on encryption, attestation, published software, and outside verification to prove what is running on the servers. Here is the twist that made people pay attention. Apple says its third-generation Apple Foundation models were custom-built in collaboration with Google. And for its most capable server model, Apple worked with Google and NVIDIA to run private cloud compute workloads on NVIDIA GPUs in Google Cloud. This does not mean every Siri request is secretly sent to Gemini. Apple describes its own Apple Foundation model family, built with Google collaboration and optimized for different hardware. The important point is more subtle. Apple is controlling the assistant experience while leaning on outside AI infrastructure where it needs scale. Apple described a family of 5 models. 2 are on-device, 3 are server-based. The server group includes a general cloud model, an image model, and a more capable Cloud Pro model for harder reasoning and agentic tool use. Different jobs get different engines. Imagine asking Siri to add milk to your grocery list. That should not need a frontier-scale model. Now imagine asking it to compare a file on your Mac, find related emails, draft a reply, and attach the right photo. That is a bigger orchestration problem. For the grocery list, the system can likely stay close to the device and app tools. The model needs to understand your words, choose the list app action, and confirm the result. The value is speed, not deep reasoning. This is where small models shine. For a more personal request, Siri may need to search your messages, emails, or photos. Apple's architecture uses on-device indexes and app connections, so Siri can find relevant personal context. The goal is to use your data for the task without turning it into training material. For the hardest requests, Siri may need a model with more reasoning power and more compute. That is where the Cloud Pro layer matters. Apple says this model supports demanding use cases like complex reasoning and agentic tool use, and it is optimized for NVIDIA GPUs. Agentic tool use means the assistant is not just answering with text. It may plan steps, call tools, check results, and take actions across apps. A basic chatbot says, "Here is a recipe." An agent-style assistant might add ingredients to a list, schedule shopping, and draft a dinner invite. Screen awareness is another major shift. If Siri can understand what is currently visible, you can refer to this photo, that message, or the chart on the screen without explaining everything. The assistant becomes less like a search box and more like a helper sitting beside you. Personal context is what makes the assistant feel useful and risky at the same time. If you ask for the hotel confirmation your friend sent, Siri may need to search messages and email. That is helpful only if the system can reach private information safely and explain where it found it. App actions are the bridge between understanding and doing. Developers connect their apps to Apple Intelligence through frameworks that describe what their apps can show and what actions they can perform. Without that bridge, Siri can talk about your goal but cannot reliably complete it. This is why Apple's developer story matters. The assistant becomes more powerful when apps expose content and actions in a structured way. A food app can expose recipes. A task app can expose projects. A photo app can expose editing actions. Siri becomes the interface across them. The bargain is simple. Users want an assistant that understands their life, but they do not want their life copied into a random cloud database. Apple is trying to say it can offer personal AI by combining local context, private cloud inference, and strict limits on data retention. But there is still trust involved. You must trust the device to route correctly. You must trust Apple's software approval process. You must trust that researchers can verify meaningful parts of the system. And when Google Cloud hardware is involved, you must trust the confidential computing stack around it. Apple's argument is that even when the hardware is outside Apple's own data centers, Apple still controls the private cloud compute software that devices are allowed to trust. Your device should only send sensitive requests to cloud software that is cryptographically approved. Google's role is different. Google provides cloud infrastructure and, according to Apple, helped build the foundation model family using technologies behind its Gemini work. NVIDIA provides the GPU hardware for the most demanding model layer. Apple is packaging that into its privacy and operating system experience. The reason is practical. Frontier AI needs huge compute, and Apple's strength has never been selling a general chatbot on the open web. Apple's strength is distribution. It owns the device, the operating system, the app frameworks, and the default assistant entry point for millions of users. That is the catch. Apple may not need to lead every public benchmark to matter. If Siri becomes the doorway to actions across the iPhone, Apple can shape how people use AI day to day. The interface layer may be as important as the model leaderboard. Still, there is a real risk. If the smartest parts depend on Google and NVIDIA infrastructure, Apple has to prove that its privacy layer and product integration are strong enough to offset not owning every part of the stack. Privacy branding will be tested by technical reality. What we know is that Apple announced a new Siri AI architecture with on-device models, private cloud compute models, and a Cloud Pro model extended to NVIDIA GPUs in Google Cloud. We also know Apple is presenting this as a privacy-first design, not a normal cloud chatbot. What we do not know yet is exactly how often real user requests will hit each layer, how well the routing works under pressure, and how the beta experience will compare with the keynote. That is the difference between an architecture diagram and a product people trust. So avoid both lazy reactions. It is not accurate to say Apple built a fully independent private AI empire. It is also not accurate to say Siri is just Google in disguise. The more interesting truth is that Apple is building a privacy-framed interface on top of a mixed AI supply chain. The big shift is that Siri is moving from a command button to a routing layer for intelligence. Sometimes the brain is on your phone. Sometimes it is in Apple's private cloud. Sometimes the hardest work may run on Google Cloud GPUs under Apple's privacy rules. And that brings us back to the question that matters. When you ask your assistant for help, where should the intelligence live? On your device, in a private cloud, or wherever the strongest model runs? Tell me what part of this architecture you want explained next.